First off, I haven't got the chance to cover enough material because of all the interruptions. Today, we get a day of instruction. And then besides that, we ain't going to get another day of instruction until Monday because fifth period's not going to be really in here tomorrow. And you all will, but I won't be here. So, there's something that I've been wanting to do for a while in chemistry, and I guess this is the year that we're going to give this a shot. You need to learn how to write a lab report. Writing a lab report is something totally different than writing a English paper. So, ain't no time like the present.
Let's do this worksheet first.
So, this is what we're going to do. In this, I'm going to teach you all how to write a lab report. And this is how things are going to be different. Part of today and on Monday is going to be instructions on how to write the lab report. And then whenever we actually get into, after Monday, Tuesday, Wednesday, Thursday, and Friday, we'll be in Computer Lab 1110, which is giving you a total
There's no school next Friday. It's a IC.
So then we're going to have Wednesday, Thursday, Tuesday, Wednesday, Thursday. There we go. Yes.
The seniors won't be here Tuesday or Thursday.
Well, it looks like y'all get Wednesday. You will write me a lab report. Within that, I'm going to be giving you a rubric. The rubric is literally how I'm going to grade everything. Along with that, I'm literally giving you a breakdown of sections. Your lab report should be broken down into sections. They should look certain ways. And within that, the ultimate goal is that you learn how to properly write a lab report so that whenever you go to college, you're not left behind. Because they are very, very different. Extremely different. It is supposed to be point and dry. It's not supposed to be a whole bunch of entertainment. It's, you know how whenever, let's just be real in here, okay? I'm not an English teacher, so I'm not going to get mad at you saying this. And you can tell your English teachers that I said this, and they can get mad at me later. But, you know how whenever we write those English papers, and we're like, man, I got to write 5 pages on this? Oh, okay. Thank you, Kevin. We don't look and say stuff like, you know, the lab coat was white. That is very simplistic. You're going to go into all these details. And the lab coat was as white as the snowy winter storm that blew through 3 years ago when the ground was covered in 6 feet of snow. Oh my, the mighty white lab coat. You're going to stretch this thing out. In other words, we call it fluff, right? Anybody who's looking at me, tell me right now, you've never fluffed an essay, you've never fluffed a paper. You are lying through your teeth. Every one of us have done it.
Necessity.
It's okay. Trust me, I bet you English teachers have done fluff too.
Oh yeah.
Normally they look for, like, oh, I want you to use your metaphors and similes. Oh, you draw foreshadowing. That is not my cup of tea. As you can tell, I like things that are point blank, straight up, like, you know. Yeah, we're probably going to use some light.
The light was bright.
See, I like things that are point blank. Like a photon has frequency of 2.68 times 10 to the 6 hertz, calculated energy. That's point blank. So this is what we're going to do. I'm just trying to give you a rundown. We'll work on this today. We should get this done. I am going to go at a quick pace, okay? I'm not going to like lollygag through this because we need to get to this. You all need to learn, part of lab reports is adding easy easily read information. Okay, graphs. Within this, a line. That line is there for a purpose.
Line of this good. So that's what that is.
So y'all done this before.
No, definitely not.
Not if you put a line through a lot of points.
Okay, but you can get an equation from that, and then from that equation we can find out information that we were looking for. What, Alyssa?
Yeah. Okay, first of all, let's add food. You're recording this, right?
What?
Are you recording this?
Yes.
Okay.
So don't ruin my video. Don't say something that's going to ruin my video.
Okay.
I'll say it if you're too
Will
scared.
do.
So you clearly want to ruin my video.
That's what I'm best at.
Okay, so in this, guys, we're going to get started on this. But that's what you're looking at. For those of you that are not want to be here, you still have opportunities, okay? Even if you do not have a computer at home, you have computers here at the school you can go to during lunch. You can type up a lab report. When I grade this thing, you're going to think I'm the most evil person on the face of the planet. Because when you leave here, I told you, my chemistry students will stack up with anybody's chemistry students in the state of West Virginia. You may not be AP students. By golly, y'all will stick up with any general ed.
Is this class later?
No,
It isn't.
no. Everybody keeps asking me that. I don't know why.
Because maybe it should be Mr. Cole.
I think it should be.
It should
I think,
be.
no, I think you should have chemistry and then AP chemistry.
I would love to have AP chemistry. I really would. Alright, so looking at this, looking at some practice problems, I'll go on and tell you with these practice problems, I just got them off the internet. I did not write them myself. A dead giveaway to how you should know that is, I never spell things out for you. That was literally spelled out for you. It even gave you what it is. I mean, look at this. Calculate the energy, E, and the wavelength.
Lambda.
My gosh, it's like everything's spelled out for you. I am not going to be that nice. Tomorrow, for you all, while you are here, guess what you will have? More of these problems to work on.
Because you hate it.
Because y'all apparently are struggle busting through these. I really didn't think these would be that hard for
But you
y'all.
already.
I got
I
1
can't
through
even
5.
pass math.
You got
How am I
my
going to pass this?
I'm dumber than
Because we're
I
not teaching.
I haven't wrote it up yet.
Only a little.
I got 1 through 5.
Alright, so in this, a photon has a frequency of 2.68 times 10 to the 6 hertz. Calculate its energy. In this case, I told you, look where you're starting. We're trying to calculate energy, so we're literally going to use the energy equation. Now from this, the key to this is to use the energy equation, we must have frequency. In this case, this problem's really simple. It already gave us the frequency, 2.68 times 10 to the 6. So we get Planck's constant, which is 6.626, or stitch as I like to call it, times 10 to the negative 34 joules seconds, times frequency, which is 2.68 times 10 to the 6 hertz. You're going to type that in a calculator.
Quick question.
Yep.
How would you feel if I just watched the today and then took it home and write it down? Like when I watched it when I get home. Can I do that? Is that allowed?
As long as you don't give me problems. So this gives us an energy of 1.7758 times 10 to the negative 27 joules. So like what I told you, problems like number 1 will be your favorite. They're very simplistic and easy. All you're doing is a straight up multiplication. You have to do no algebra. It requires no algebra skills whatsoever.
So the 6.626 times 10 to the negative 34, what is that again?
That is Planck's constant. That is H. And it's your first constant you must memorize.
Okay, so what is
Second constant you must memorize.
2.98 times 10 to the 8?
That is the speed of light. That is C. That is the second constant you must memorize.
What?
Alright, from here, moving on. We're looking at calculating the energy and wavelength. So we're doing energy. I'm going to do energy in red. And wavelength of a photon of light. Wavelength in blue. Of a photon of light with a frequency of 6.165 times 10 to the 14th hertz. So in this, do the easiest one first, in my opinion. I'm going to have to write smaller on this one. Energy equals Planck's constant times frequency, which will be equal to 6.6 times 10 to the negative 34 joule seconds. Remember, it's joule times seconds. Be multiplied by 6.165 times 10 to the 14th hertz, which is inverse seconds, so it cancels out with the seconds, leaves me with joules. This is what I'm looking for. And our calculator, 6.626 times 10 to the negative 34 times 6.165 times 10, 14 in parentheses gives me 4.0849 times 10 to the negative 19 joules. There is my energy on that one. Now we're looking for wavelength. This is the ones that I think nobody likes because it requires some skill from algebra. So the speed of light equals wavelength times frequency. I'm trying to find wavelength, so wavelength is equal to the speed of light divided by frequency. For all of you that are not understanding what I just did there, you are either juniors or seniors in high school. I'm not going to baby you. To get from the speed of light equals wavelength times frequency, all I did is divide by frequency because we're multiplying wavelength and frequency together. So I did the opposite of what's being done. I am not writing that down. If you are struggling with that simple algebraic thing there, you need to come see me because I personally promise and guarantee you that this is just baby level of the algebra skills you're going to need in this class. This is a forewarning. So plugging in the information, 2.98 times 10 to the 8 meters per second divided by frequency. In this case, it was given to us 6.165 times 10 to the 14th hertz. And we will find .8337 times 10 to the negative 7 meters because hertz and seconds cancel out. And there's that one. Question you, do I need to put that nanometers?
So if we get one like this on the test, we would get 2 checks, right?
Yes. This one will be worth 5 points and that one will be worth 5 points. Unless I broke it into 2 separate questions. Then that one will be worth 10 points and that one will be worth 10 points.
Where there's been such a gap between our first and our next test, is there going to be more problems than on the last? Where you covered
If I get to cover everything that I'm wanting to cover before your next quiz, there absolutely will be more questions. And typically when I get to this unit, that happens anyway. It's not because of the big gap of certain stuff that we've covered. We haven't really covered a lot. That's the thing. That's why we're doing the lab report now. And from that lab report, I want to tell you that lab report's going to stick in like a quiz grade. That's why on Friday, I'm going to look and say, Friday I want the lab reports. But if you don't get it to me by Friday, it's not gonna count against you. You can still turn the lab report in at a later time. You don't need to freak out about it. But whenever I'm grading them, and it'll take me a little bit to grade them, because I'm gonna go through these things with a fine tooth comb. In that, you're going to I'm just gonna be a medium in a grade. There ain't no other way to say it. Like, I'm literally gonna prepare y'all because y'all are so used to writing an English paper, you're not ready to write a lab report like this. Y'all really gonna think I'm being really mean, which is why you don't just get one time to write it.
Did you give us our, like, did you have the rubric done today?
I got the rubric, I got it. It's all typed up, I just have it printed.
Did you?
You will have it.
I just want to, can we get started early, like if you see it to remind?
There's no possible way y'all are gonna be ready for this. Yeah, you need the instructions I'm gonna give in class. Do you know how to work Excel and make graphs?
Probably not, no.
That's the problem. You guys need that instruction from the class. You're gonna have plenty of time, Melissa. You don't need to freak out over this. Number 3, calculate frequency and energy of the light that has a wavelength of 400 nanometers. So in this case, we're going to do energy in red and frequency in blue. See, now this question's more like it, ladies and gentlemen. Number 3 is a question I would give you. And in this, think carefully. You have wavelengths. You do have to do a conversion. What would make more sense to start with? Solve for frequency or energy?
Frequency.
Why frequency?
Because you use frequency in your energy equation.
You have to have frequency to get to the energy. So we're going to start with frequency. Now, first thing in this is you got a problem. Gone already pointed it out. You're at 400 nanometers. You're trying to find frequency. Speed of light equals wavelength times frequency. So we are using frequency is equal to the speed of light divided by wavelength. And the speed of light is 2.98 times 10 to the 8 meters per second. Can you use 400 nanometers? No. I got a head shake, so I'll take that. Divided by, what we got to get that to? Meters. 400 times 10, negative 9 meters. Yes, I'm starting to pull on y'all. I'm not going to spell out how I got to that. We've been doing that for a month. Nano, negative 9. Negative 9 minus 0, because meters is the base unit, equals negative 9. That's how I got the exponent of negative 9. Now, bless you, find the answer from here. We're going to have 2.98 to the 8th power divided by 400. Gives me 7.45 times 10 to the 14th hertz. So there's one. Now from here, we're going to need that information right there. This is typically what I'll do is I'll store it in A. This is why a lot of our answers are different. They differ. So in this, we're now trying to find energy is equal to Planck's constant times frequency. Planck's constant is 6-point stitch. Joule seconds times, let's do this so you guys see where this is coming from. 7.45 times 10 to the 14 hertz. This is a really good problem simply because you have to solve one part to get to the other. And I like that. So in this, this is typically what I'm going to punch in my calculator. I'm just going to hit multiply because it's taking the answer, which is our frequency from what we had before, multiply it by 6.626, negative 34, gives me 4.936, 4 times 10 to the negative 19 joules. Any questions? What I do, let me see if I can get it up here so you can see it, is right here above the on button where it says on here. You see that STO with the arrow? Once you hit that, it'll take the answer. So like what we just got there, and then hit alpha, and all those green letters on there. Let's see if I can zoom in. So you see the green letters? A, B, C. So if I want to use B, I'd hit the apps button. Once I do that, you see it hit B for me. I like to use that because it saves all the data because I care about my accuracy and precision. Any questions there? I will be honest with you, that was a really good problem there. I mean, that's pretty much like a good difficulty level that you're going to be looking at. No questions. How many of y'all done number 4? Give number 4 a shot. You can work in groups. You're fine. You don't need to feel the need to whisper quietly amongst yourselves.
But number 6.
It's a good question. It's one of those that
I think that's right.
well, when you think about it, when I explain it to you, explain it to you, and you've thought about it, you're going to like really kick yourself.
And just the part where it just has that number of photons that you're on.
Think about it. Calculating the photons have been wavelength of 10.0 micrometers required to produce 1.0 kilojoules of energy. That right there, that measurement, that 10.0 micrometers,
Did the conversion.
yes. But that's for a single photon. So if I calculate how much energy one photon has, all I need to do is work. Just convert to see how many I need to get to that 1,000 kilojoules. Yeah. You were right, by the way. That point, you only time we told me we didn't have to work at nanometers. I never addressed that, it was normal.
What those numbers is. No. Number six. Yeah, she's not. We did it anyway, though, Mr. What? Kimberly did it.
You have an answer for something? Are y'all ready? Number 4. In case you cannot see that, a little bit. So for energy of the photon, I get 9.939 times 10 to the negative 19 joules. And the wavelength of the photon is 1.9867 times 10 to the negative 7 meters. Do we need to convert that to nanometers? No, there's no need. The only way I convert that wavelength to nanometers is if I was asked to identify what type of electromagnetic radiation that was. It's the only way. And when you're dealing with problems like that, those are the hardest problems that I can give you. Okay? Alright, I'm going to skip 5. We've done one like that before. You should have no problem with it. And I'm going to jump to 6, which Connor's got the question on. How many of you think you have an idea of how you can work 6? Six is really good. It's a really good problem. It's one of those that I left because I wanted to pull on you. I wanted to see if you could think. Inside this class, it just isn't about just doing time and time again what's been given to you. It's about thinking critically. So you need to think a little bit about what you're solving for here. So in this case, calculate the number of photons having a wavelength of 10.0 micrometers required to produce 1.0 kilojoules of energy. So in this, we need to calculate And here's the key. Right here.
Would you convert that?
You will convert that. That 10.0 micrometers must be converted, but this is the key to it. That's the wavelength of these photons. That's the wavelength for one of those photons. We can use that wavelength to calculate out the energy for one of those photons. Once we have the energy level for one photon, we can work from the energy we're trying to produce and calculate out how many photons it will take. So in this, we need to find the energy. We have wavelength, so we need to first calculate what?
The KTJ.
Nope. Frequency. Remember, you're either going to find, through, or starting with frequency. Frequency is the key. So in this, we got to find frequency. Speed of light equals wavelength times frequency. Frequency is equal to speed of light divided by wavelength. If you're not understanding how I'm doing these, you need to come see me.
I have a question.
Yep.
On number 4, on the second one you put 2.98 times 10. You didn't put to the A's. Is the problem like is the answer still right?
Let me check my calculator.
Is
Yes.
so much. Sorry.
I added that back in. 2.98 times 10 to the 8. Good catch. I was testing you. Not really. I just forgot to write it. Times 78 meters per second. That's divided by wavelength, which is 10.0 times 10 negative 6 meters. Meters cancel, leave me with inverse seconds. So 2.98. The 8 divided by 0 6 next is I get 2.98 times 10 to the 13th. And those are inverse seconds. That's equal to hertz. Zoom out. I wrote it like this, so if you see I wrote it like this on a quiz or something, you don't freak out. Inverse seconds, that second to the negative power is inverse seconds, which is equal to hertz. Now in this, we need to calculate out the energy for one of these photons. So energy equals Planck's constant times frequency, just 6-point stitch. Let's do it this way, so you don't freak out and know where its numbers came from.
We're gonna use your,
Now just use it straight from the calculator. You don't have to use the, you don't have to switch it.
not that, that's what you.
Alright, so we get that energy. Now this is the key. This is the energy source for one photon. You can now use this information to calculate this out. First thing, it's literally this simple. How many photons are we in need of to produce that amount of energy? Are you ready?
You deal with that.
Is that how you would do it?
First, got to convert. 1.0 times 10 to the third joules. And this is what I get.
Mr. Hall,
Yep.
for that purple one, the times, what is it? I can't say it for joules.
Photon.
Is there a way we write? Okay. You just-
Now in this, think about this. Yeah, we'll leave it like that. That's fine.
I didn't know if there was abbreviations for photons or anything. Scientists have abbreviations for everything.
Some things you just spell out,
Just
like photon.
Wait, so if you didn't know the abbreviations or something, like a unit, and we wrote the word out, would you count it wrong?
So if you guys wrote out micrometers,
I mean, I know the abbreviation for that, but let's say that I did, and then you still count it wrong.
if you do not know the abbreviation for micrometers, and that is what you would have ended with in your problem, and you wrote out micrometers, I'm going to give you credit. Because this is the thing. I don't believe you have the opportunity to randomly work through this, get the right number, and look up and get your units. There's no possible way, okay, you can work from this and know that your units are photons just by the question. But to even get close to that number, if you have no idea whatsoever, you have no clue on the math, there's no way you're going to chance on that number. There's no way by luck you just end up getting there. You're either going to have a plan how to get there or not. It's like right here on all of these. I'm labeling everything out. Meters per second, meters cancel, leaves me with inverse seconds. Joules seconds, inverse seconds. Seconds cancel, leaves me with joules. So to answer your question, yeah, I'll give you credit if you write it out, but I will be completely shocked if somebody in this room can randomly just stumble upon and get the right units. I will be impressed. Any questions? That one was pretty hard. We end up needing 5.0645 times 10 to the 22nd photons. That's a whole lot of photons.
So it's basically kind of just like the last lesson we had, like with the moles, it's just we different units.
That's what you're looking at in everything you do.
All it is just converting.
Not exactly. These are not like conversions. These are actual calculations. These are relationships. These two formulas are relationships that they came up with. And from that, you're actually doing calculations. You're not doing, per se, conversions. Alright, so this is y'all's video. Today in 5th period, I will work on the second half of this worksheet. Tomorrow when you guys come in, I'll have some practice problems for y'all on electromagnetic radiation. Also, along with that, you will be coming here, not in this class Monday, No, yes, Monday you'll be coming to this class, but the rest of the week we'll be going to lab 1110. Okay, I will post a sign on the door so it's there for you.